Hi, we're going to have a little lesson about Punnett squares. I realize Punnett squares are review for a lot of us, but your textbook doesn't cover them very well and they can be a little bit confusing. So first let's talk about chromosomes. Remember, your chromosomes come in pairs. They come with a buddy. You got one homologous chromosome from mom and one from dad, and those chromosomes have information on them, and that information codes for the same traits but might have different information for each trait. So let's say that you are a pea plant. We will say that you are a female pea plant just for the sake of argument, and that you have purple flowers, but you are heterozygous for purple flowers. What that means is that one chromosome will say this one has information for purple flowers, and one chromosome will say this one has information for lowercase flower, or has the information for white flowers. We represent the purple flower information with a capital P because it is dominant. We represent the white flower information with a lowercase p because it is recessive. I want you to understand that this chromosome here doesn't actually have a capital P on it. It has information for purple flowers, which we are representing with a capital P. And the other chromosome has information for white flowers, which we are representing with a lowercase p. This is your genotype, capital P, lowercase p. It represents the information that is actually on your genes. But the phenotype of your plant is purple flowers because the capital P masks out that lowercase p. The capital P is dominant to the lowercase p. That is, purple flowers are dominant to white flowers. So your phenotype is purple flowers, but your genotype is capital P, lowercase p. We're going to do a Punnett square, and that Punnett square is going to represent a cross between you and another heterozygous individual. Now, if you had two capital P's, you would be a homozygous individual. Homozygous means the same, and heterozygous means different. We're going to do a cross between two heterozygous individuals. So we're going to put your information on the left-hand side here. You have a capital P and a lowercase p. And the plant that is donating pollen to this cross also has a capital P and a lowercase p. So you're each going to make gametes. When you make eggs, you can make two different kinds of eggs. You can make an egg that has a capital P. It has information for purple flowers. Or you can make an egg that has information for white flowers. Those are the only two different kinds of gametes you can make. Your mate also can make two different kinds of gametes. He can make gametes with information for purple flowers, a capital P, or he can make information for white flowers, a lowercase p. So you see that the probability of any of your offspring having two capital P's, that is being homozygous for purple flower color, is 1 out of 4. That is 25%, right? The probability that any of your offspring is heterozygous for flower color, that is having a purple allele and a white allele, is 2 out of 4. That is 50%. And the probability of your offspring having two white flowered alleles is 25%, or 1 out of 4. So remember, probability is a funny thing. The probability of having a boy versus a girl is 50%. The probability of heads versus tails on a coin is 50%. Now, you can flip a coin and get heads 4 times in a row, just the same way that you can have a family with 4 boys or a family with 4 girls. Just because the probability is 25%, 50%, and 25% doesn't mean that that you're going to have 25% of the offspring be that color or have that genotype. Genotype is the actual genes again, and phenotype is what it looks like. So the lowercase p flowers, their phenotype is going to be white flowers. The heterozygous flowers will be purple flowered, and the homozygous flowers with the two capital P's are also going to be purple flowered. So if we're going to talk about phenotypic ratios, let's talk about phenotypic ratios for a second. So the phenotypic ratio of purple, which I'm writing in blue, which makes perfect sense, is 75%. It's 3 out of 4. You have a 75% chance of having purple flowered plants. And the phenotypic ratio of a white, the probability of having white flowered plants is 25%, the same as the genotypic ratio. That's just a little bit of information about Punnett squares. Again, it should be review, but if it is not, and if some of that vocabulary is a little bit confusing, I hope that was helpful. Thank you.